Okay, get started here. So greetings, Physics 151. So this is a video, I say again, about the first homework assignment for the class. So chapter one's homework assignment is going to be posted the day of I post this video in the class on Moodle. So everyone, the thing about chapter one, if you already taken it, if you already read chapter one, hopefully you've already read chapter one, seen the voice thread that I posted about chapter one and etc. But everyone, chapter one pretty much is a review of the different mathematics that you have covered up until now. Let's say before you took this class. It's also, of course, chapter one is dedicated to defining what exactly is physics. So I won't go into like details about that again because I've already did that in my overview videos. But anyway, everyone, about the homework itself, and I'm trying to keep this one fairly short. I'm not going to work a problem in this video, mainly because that takes quite a while, and I have other videos for that. And if anyone wants more information about working problems, like if for homework or anything you see in homework that you do not understand naturally, you can ask me. So that's what I'm here for. Okay, so so this video is be dedicated to some tips about say chapter one. So first of all, most of the problems through chapter one that you're gonna see for homework, they're gonna be essentially either related to significant figures, unit conversion, and like I say again, you got materials about that. You have materials about that already in Moodle. Also, it's dedicated to doing various math problems that's related to it's correlated to physics, but more or less they're general math problems that you're going to see throughout, say, chapter one. So, for example, you might have let's say again, problem dealing with similar triangles. And what I mean by similar triangles, everyone, that's a technique. If if I want to draw it on the board real quick, let's say for example, hopefully everybody can see this. Let's say, for example, I have a building and I have a person standing in front of that building. And what happens is that this person makes a is off, like say again somewhere. They're looking down the ground, and so that forms as one side of a triangle as you look down the ground. And then what happens is you go up from the head to the person to the top of the building. That's not a great drawing because I'm not using straight edge. But everybody, you can imagine if I look up if I'm the person looking up to the top of the building, let's say again between my body and to the ground, you're forming two triangles. So by using the technique of similar triangles, you say you can estimate what's the height of that building. Okay, and for those not familiar with the similar triangles technique, after you see this video, you can ask me about it. But you will see it example of it rather in chapter one in your ebook. So take a look at, like I say again, some examples throughout chapter one. So I say again to review that technique. But again, that's similar triangles. But as far as my tips, those that's kind of far. The board's kind of far away, so I'll just read off, like I say again, what I've written on the board already, just in case you cannot read that as you review this video. First thing is review mathematical formulas. Okay, this is an algebra-based class, and one of the things about algebra-based physics, you're going to be using a lot of algebraic formulas or a lot of geometric formulas, which geometric formulas are algebraic in nature. So, and what I mean by algebraic, we of course mean that you have like some knowns and unknowns, or you're basically using that formula to solve for your unknowns. Okay. So, like say for example, area. If you know like the area of a square, if you know the length and the width of the let me say length because of squares, length and width is the same thing. Let's say area of a rectangle. If you know the area of to get the area of a rectangle, if you know the length and the width, like I say again, you can calculate the unknown, which would be of course the area. So review those like formulas. Areas are good formulas to review. Volume is also good ones to review. If you do not, and I say again, if you don't remember those formulas that well, you can use as I said on the board here, number three, you can use the ebook's appendix. There's several appendices for the ebook, appendix A and B, and basically those appendices are dedicated to reviewing a lot of mathematical formulas. So go in your so open up your ebook, go to like the mastering course, open up your ebook, and you go to the look at the table of contents and go to the appendix, and you'll find these various mathematical formulas. Now, if you don't want to look at that stuff online, of course you can get these. You can find mathematical formulas online as well. But I would suggest this: buy yourself a math table, or get like a book of math tables. And when I was in college myself, Shams outlines of Shams outlines of mathematical formulas and tables. That's a book. It probably costs you no more than $10, $20 these days. But get a copy of that, and that will actually serve you well in this course. It's got the same information that's in the appendix of the textbook, but it also is hands on. You don't have to worry about like linking up to the internet or linking up to the ebook to actually say read it. Say again, go. I say you can actually have it in your hand and just look at it wherever you want to. And it's good to have some things that are not electronic. Something we often forget in this world where we got a lot of electronics going on. But everyone, another thing we want to review is trig identities. So in addition to your geometric formulas, like for area and volume and things like that, review your trig identities. So what's an example of a trig identity? There's a lot of trig identities, but I put two examples on the board. One is this: sine of 2 theta. When you talk about the sine of 2 times the angle theta, that's equal to 2 times the cosine of that angle multiplied by the sine of that angle. Okay. So like I said again, if you can't see the board, let me actually rewrite it here, just in case you can't see the board. And let me use a different marker. And bear with me for a moment, everyone. But not disregard that. Okay. This is what I'm talking about. So sine 2 theta is equal to 2 cosine theta times sine theta. Not so much this chapter, but and some of you may get problems on trig identities. Many of you probably would not. But this is good to review because you will be using this pretty soon. Matter of fact, in the next chapter, we're gonna be using this identity as like to help figure out or derive rather a few formulas we're gonna be using. So another identity, the other one I put on the board, and I believe this one is very familiar to many of you, if not all of you, should be familiar to everybody. But sine theta squared plus cosine theta squared is equal to 1. Okay, that's a good one to I say keep in mind as well. Okay, and so like I say again, but there's various others like I say again trig identities out there, and I would say this: go ahead, just go into the appendix and just make a tape, just get that table of different trig identities, and just have that available to be used if necessary. Okay, so a lot of this is if necessary sort of things. But again, you will see the problems you do for chapter 1 rather. You will be doing things where involving areas and volumes and things like that. In addition to significant figures, converting, say unit conversion, and like say things like that. Another thing too is yes, do not rely on AI. I know it's easy these days. Just go ahead and just like I don't have to ask Mr. Perry any questions. He just there, say again to like give me work to do. So I'm not gonna ask him anything. I just go to Google or I just go to AI or just go do check and all that kind of stuff. Or I just go to YouTube. And everyone, that's fine and everything as far as like you're working out the problems, but you're really robbing yourself of the process of learning how to work these things out. And a lot of you are not going to be doing a lot of math on your say again your future careers, but you do want to have the develop the ability to analyze and evaluate problems. And so that's something we all do, whether it's mathematically related or not. We all analyze and evaluate problems. So you want to actually like say go through that process, and it kind of like I'll be honest, consulting a source that just works out everything for you, or consulting somebody or getting somebody to just work the problem out for you, it really say again robs you of the what I want to say the elation of figuring things out for yourself. And trust me, when you figure something out for yourself, it's one of the best feelings in the world. You know what I'm saying? So if I want to have a little soapbox moment, I just want to put that into the video. But anyway, everybody, I will stop there. And if you have any questions, feel free to ask me after you see this video or through the process of you working out your homework. If you have any questions, let me know.